Alright, this is lesson 9.1. We're going to do trig review again. This time trig with the calculator and the graphs of trig functions. So, remember that when you're using a calculator with trig functions, it's important that the calculator is in the correct mode. Calculus, the mode has to be radians, okay? Radians. So, if I ask you to use a calculator to find these ratios, then pull out your calculator. Make sure your mode is set to radians. Turn it on first, yeah. Set to radians. Yeah, mine is. It's highlighted. And then you're ready to actually just punch everything into your calculator. So sine of 2, and that this means 2 radians, is 0.909. Okay, remember this is radians. Tangent of negative pi divided by 5, negative 0.727. Secant, remember, is 1 over cosine of 1.3. So I'll evaluate 1 over cosine. So 1 divided by cos of 1.3 radians. That's 3.738. Okay. Now, if we're not using those special angles that we reviewed from the last lesson, then we have to use a calculator to evaluate. So in this case, I have the angle, I have, I guess, the opposite side, I have the hypotenuse, or I want to find out the hypotenuse. So you should be thinking, which trig ratio should I be using? Sine. And this is now sine of 0.5 radians is equal to opposite over hypotenuse. To solve for x, we'll just do some division then. So 5 divided by sine 0.5. This I can't do in my head, neither can you. So go to your calculator, punch it in, get the answer of about 10.429. Part B, we're trying to find the angle. So in this case, once again, I have the opposite, I have the adjacent side. So hello, tangent ratio, opposite over adjacent. So therefore, to figure out the angle theta, you're doing the inverse tangent of 2 over 5. This is where I go back to my calculator. Inverse tangent, because you're trying to find the angle, 2 over 5. And you'll get the answer of about 0.381. And of course, this is radians. Okay? Cool. You should have also learned in pre-calc 12, I think we spent a whole chapter on that, graphing trig functions. Remember, they are periodic. And so you should have actually the basic trig functions memorized, the graphs. So sine, of course, you're starting at 0, it's 0. Pi over 2 is 1, pi is 0. 3 pi over 2 is negative 1, 2 pi. These are what they call those key points. Connect them in a nice curvy shape, and there you go. There's one cycle of sine. Cosine starts at 1, then 0, negative 1, 0, 1. Don't draw a V shape like that. Remember, curvy. We can talk about concavity if you wanted to. Now, how about these two, C and D? Cosecant's interesting, because cosecant really is 1 over sine. So here you're going to use your reciprocal ideas. So how do I graph out the reciprocal graph? Hopefully you understand that the reciprocal of the y value of 0 is undefined. So notice we have an asymptote at 0, at pi, and also at 2 pi. Notice also that if I took a small value of y and I did the reciprocal, it becomes big. So big values of y up to, what's the reciprocal of 1? Yeah, it's just 1. So big becomes like up to 1. And then these points here getting small again. So the reciprocal of small numbers becomes big again. Similarly, Over here, these are negatively big, so, or sorry, negatively small, so the reciprocal of small are big. Notice I shouldn't go to 0, I should only go up to -1. And so here is your cosecant graph. And once again, we do the same thing with cosine of x. Notice that wherever I have the 0, I get asymptotes. I've got what they call invariant points at 1 and -1. And of course, you just get these type of graphs here. Okay, that's one cycle. You can always extend these. These are all periodic, so you can extend them, right? And so on. Got that? Yeah? 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 Ooh, tangent and cotangent. So tangent's a little bit more funny, because I hope you remember that it's not defined at -π/2 and π/2. Notice that the tangent graph's period, the length of the graph, is also pi units, not 2π, as in the sine and cosine graphs. And if you did this properly, you should have got the graph looking like this. Whee! And the cotangent graph is the reciprocal of tangent. So your asymptote is at 0. And remember, big becomes small, and small becomes big, so I hope you see something like this. Whee! Similarly over here. Whee! And if you want to extend this in the graph, you can extend it like that. And there's your example of the tangent graph. Whee! Sorry, not tangent, cotangent graph. Cool. Pre-calculus 12 also allowed us to actually graph functions with adjustments, changing, shifting, all that stuff. Remember, the period for both sine and cosine are always 2π divided by b, where b is like the horizontal compression or expansion. Tangent, cotangents, once again, is pi, because that's the normal period is pi. Amplitude is always the a value, which is like a vertical expansion. Okay. And then your horizontal shifts and the vertical shifts are your c and b values. Okay? So, I hope you remember this, because we also did this stuff in Pre-Calc 12. If you think about how to graph this out, I think about what type of transformations occurred from the regular cosine graph. That negative, of course, is a reflection in the x-axis. I hope you remember that. That 5 is a vertical expansion by a factor of 5. And this divided by 2 is a horizontal, this is the weird one, compression or expansion. Do you remember? Horizontal stuff is always opposite. This is a horizontal expansion by a factor of 2. And if you want to go back up to the graph here and figure out this period, this would be 2π divided by the b value, which is 1/2. So we've actually elongated the period. Instead of having it being 2π, it's now 4π. Okay? So I don't know how you want to do this. I always like to do the expansion and then reflections and then translations. So in this case, if I were to take the regular graph, and you don't have to do this, but if I take the regular one goes like this. If you can draw it in one step, by all means go ahead. I'm just trying to show you the steps. Expanding it, meaning horizontally, means you're going to double the length. So here, here, like this. Whee! I forgot about vertical expansion, so don't start at 1 but start at 5 and go to -5 down here. So whee! And the last thing I forgot to do was, oh yes, the reflection. So I should really be doing this. Whee! You can make the sound effects yourself as well. And there is one cycle. To do another cycle, I'll just draw another cycle. There you go. Okay. Don't get tricked when you see stuff like this, because you should factor out that 2, and in this case, then be able to see, oh yeah, horizontal expansion by a factor of 2, and also a phase shift or a horizontal shift of pi over 4 to the right. And so if I were to graph the original sine graph, that's 0, pi over 2, pi, negative pi over 2, pi. And then I'm doing a horizontal, oops, I made a mistake. Not expansion, compression. Remember, always opposite with the horizontal business. So instead of this like graph, now I've shifted it horizontally like that. Not shifted horizontally, compressed horizontally. And then finally I'm shifting it pi over 4 to the right, which means I'll move everything to the right 1 unit. There is 1 cycle. Erase, erase, erase. And if you want to do 2 cycles, then just continue on. Cool. Once again, this is all review, so I'm not spending too much time, and I'm going pretty fast. Remember those trig identities you did in like Unit 6 of Pre-Calc 12? Yeah, those are back, because sometimes in calculus, you're going to have to use one of those identities to substitute values. Because it's hard to solve a trig equation with multiple trig ratios. But if I can just change everything into either cosine or sine, then that can help me out greatly. And so in this case, it's up to you which one you want to do, but I'm thinking I see sine squared, and so if I were to isolate one of these Pythagorean identities, which is, I think, something that you should have memorized in Pre-Calc 12, I know I made my students do it, then in this case, sine squared theta equals to 1 minus cos squared theta. And so you can rewrite your equation as replacing the sine squared theta with 1 minus cosine squared theta, which allows us to have the following. Distribute, distribute. Move everything to one side. Ooh. Square term, linear term, constant. Yeah. Time to factor. I think you get cosine theta plus 1. Cosine theta plus 1, which is great since this equals to 0, then I just have to solve one of these. So cos theta equals to negative 1. When is theta equal to negative 1 for cosine? Think back to what we did in the review of 8.5. Or think about the unit circle. Hopefully you realize that cosine is the x value, and the x value is equal to negative 1 when theta equals to pi. And that's your answer for this one. Alright? Hopefully you had a good review. Once again, more practice available for you in assignment 9.1.